The exploration of Mars has taken place over hundreds of years, beginning in earnest with the invention and development of the telescope during the 1600s. Increasingly detailed views of the planet from Earth inspired speculation about its environment and possible life even intelligent civilizations that might be found there. Probes sent from Earth beginning in the late 20th century have yielded a dramatic increase in knowledge about the Martian system, focused primarily on understanding its geology and habitability potential. Engineering interplanetary journeys is very complicated, so the exploration of Mars has experienced a high failure rate, especially in earlier attempts. Roughly two-thirds of all spacecraft destined for Mars failed before completing their missions, and there are some that failed before their observations could begin. However, missions have also met with unexpected levels of success, such as the twin Mars Exploration Rovers operating for years beyond their original mission specifications. As of September 24, 2014, there are 2 scientific rovers on the surface of Mars beaming signals back to Earth, and 5 orbiters currently surveying the planet: Mars Odyssey, Mars Express, Mars Reconnaissance Orbiter, Mars Orbiter Mission and MAVEN. To date, no sample return missions have been attempted from Mars, and 1 attempted return mission for Mars moon Phobos has failed. On January 24, 2014, NASA reported that current studies on the planet Mars by the Curiosity and Opportunity rovers will now be searching for evidence of ancient life, including a biosphere based on autotrophic, chemotrophic and or chemolyte-autotrophic microorganisms, as well as ancient water, including fluviolacustrine environments that may have been habitable. The search for evidence of habitability, taphonomy, and organic carbon on the planet Mars is now a primary NASA objective. Recent missions. NASA's Mars Odyssey orbiter entered Mars orbit in 2001. Odyssey's gamma-ray spectrometer detected significant amounts of hydrogen in the upper meter or so of regolith on Mars. This hydrogen is thought to be contained in large deposits of water ice. The Mars Express mission of the European Space Agency reached Mars in 2003. It carried the Beagle 2 lander, which was not heard from after being released and was declared lost in February 2004. In early 2004, the Mars Express Planetary Fourier Spectrometer team announced the orbiter had detected methane in the Martian atmosphere. ESA announced in June 2006 the discovery of Ori on Mars. In January 2004, the NASA twin Mars Exploration Rovers named Spirit and Opportunity landed on the surface of Mars. Both have met or exceeded all their targets. Among the most significant scientific returns has been conclusive evidence that liquid water existed at some time in the past at both landing sites. Martian dust devils and windstorms have occasionally cleaned both rovers' solar panels, and thus increased their lifespan. Spirit rover was active until 2010, when it stopped sending data. On March 10, 2006, the NASA Mars Reconnaissance Orbiter probe arrived in orbit to conduct a 2-year science survey. The orbiter began mapping the Martian terrain and weather to find suitable landing sites for upcoming lander missions. The MRO snapped the first image of a series of active avalanches near the planet's north pole, scientists said March 3, 2008. The Mars Science Laboratory mission was launched on November 26, 2011 and it delivered the Curiosity rover on the surface of Mars on August 6, 2012 UTC. It is larger and more advanced than the Mars Exploration Rovers, with a velocity of up to 90 meters per hour. Experiments include a laser chemical sampler that can deduce the makeup of rocks at a distance of 7 meters. The Indian Space Research Organisation launched its Mars Orbiter mission on November 5, 2013. It was successfully inserted into Mars orbit on September 24, 2014. India's ISRO is the 4th space agency to reach Mars, after the Soviet space program, NASA and ESA. Martian system. Mars has long been the subject of human fascination. Early telescopic observations revealed color changes on the surface that were originally attributed to seasonal vegetation as well as apparent linear features that were ascribed to intelligent design. These early and erroneous interpretations led to widespread public interest in Mars. Further telescopic observations found Mars' 2 moons, Phobos and Deimos, the polar ice caps, and the feature now known as Olympus Mons, the Solar System's tallest mountain. These discoveries piqued further interest in the study and exploration of the red planet. Mars is a rocky planet, like Earth, that formed around the same time, yet with only half the diameter of Earth, and a far thinner atmosphere. It is a cold and desert-like surface. It is notable, however, that although the planet has only 1/4 of the surface area of the Earth, it is about the same land area, since only 1/4 of the surface area of the Earth is land. Launch windows. The minimum energy launch windows for a Martian expedition occur at intervals of approximately 2 years and 2 months, that is 780 days. In addition, the lowest available transfer energy varies on a roughly 16-year cycle. For example, there was a minimum in the 1969 and 1971 launch windows, rising to a peak in the late 1970s, and hitting another low in 1986 and 1988. Image map of Mars landings. The following image map with the planet Mars has embedded links to geographical features in addition to the noted rover and lander locations. Click on the features and you will be taken to the corresponding article pages. North is at the top. Elevations, red, yellow, blue. Overview. The following entails a brief overview of Mars exploration, oriented towards orbiters and flybys. See also Mars landing. Early Soviet missions. 1960s. Between 1960 and 1969, the Soviet Union launched 9 probes intended to reach Mars. They all failed, 3 at launch. 3 failed to reach near-Earth orbit. 1 during the burn to put the spacecraft into trans-Mars trajectory. And 2 during the interplanetary orbit. The Mars 1M programs was the first Soviet unmanned spacecraft interplanetary exploration program, which consisted of 2 flyby probes launched towards Mars in October 1960, Mars 1960A and Mars 1960B. After launch, the third stage pumps on both launches were unable to develop enough pressure to commence ignition, so Earth parking orbit was not achieved. The spacecraft reached an altitude of 120 km before re-entry. Mars 1962A was a Mars flyby mission, launched on October 24, 1962 and Mars 1962B a lander mission, launched in late December of the same year. Both failed from either breaking up as they were going into Earth orbit or having the upper stage explode in orbit during the burn to put the spacecraft into trans-Mars trajectory. Mars 1, an automatic interplanetary spacecraft launched to Mars on November 1, 1962, was the first probe of the Soviet Mars probe program to achieve interplanetary orbit. Mars 1 was intended to fly by the planet at a distance of about 11,000 km and take images of the surface as well as send back data on cosmic radiation, micrometeoroid impacts and Mars' magnetic field, radiation environment, atmospheric structure, and possible organic compounds. 61 radio transmissions were held, initially at 2-day intervals and later at 5-day intervals, from which a large amount of interplanetary data was collected. On March 21, 1963, when the spacecraft was at a distance of 106,760,000 km from Earth, on its way to Mars, communications ceased due to failure of its antenna orientation system. In 1964, both Soviet probe launches, of Zond 1964A on June 4, and Zond 2 on November 30 resulted in failures. Zond 1964A had a failure at launch, while communication was lost with Zond 2 en route to Mars after a mid-course maneuver, in early May 1965. In 1969, and as part of the Mars probe program, the Soviet Union prepared 2 identical 5-ton orbiters called M69, dubbed by NASA as Mars 1969A and Mars 1969B. Both probes were lost in launch-related complications with the newly developed Proton rocket. 1970s, the USSR intended to have the first artificial satellite of Mars beating the planned American Mariner 8 and Mariner 9 Martian orbiters. In May 1971, one day after Mariner 8 malfunctioned at launch and failed to reach orbit, Cosmos 419, a heavy probe of the Soviet Mars program M71, also failed to launch. This spacecraft was designed as an orbiter only, while the next two probes of Project M71, Mars 2 and Mars 3, were multi-purpose combinations of an orbiter and a lander. They were successfully launched in mid-May 1971 and reached Mars about 7 months later. On November 27, 1971, the lander of Mars 2 crash-landed due to an onboard computer malfunction and became the first man-made object to reach the surface of Mars. In December 2, 1971, the Mars 3 lander became the first spacecraft to achieve a soft landing, but its transmission was interrupted after 14.5 seconds. The Mars 2 and 3 orbiters sent back a relatively large volume of data covering the period from December 1971 to March 1972, although transmissions continued through to August. By August 22, 1972, after sending back data and a total of 60 pictures, Mars 2 and 3 concluded their missions. The images and data enabled creation of surface relief maps, and gave information on the Martian gravity and magnetic fields. In 1973, the Soviet Union sent 4 more probes to Mars, the Mars 4 and Mars 5 orbiters and the Mars 6 and Mars 7 flyby-lander combinations. All missions except Mars 7 sent back data, with Mars 5 being most successful. Mars 5 transmitted 60 images before a loss of pressurization in the transmitter housing ended the mission. Mars 6 lander transmitted data during descent, but failed upon impact. Mars 4 flew by the planet at a range of 2200 km, returning once-wave pictures and radio occultation data, which constituted the first detection of the nightside ionosphere on Mars. Mars 7 probe separated prematurely from the carrying vehicle due to a problem in the operation of one of the onboard systems and missed the planet by 1300 km. Mariner program. In 1964, NASA's Jet Propulsion Laboratory made 2 attempts at reaching Mars. Mariner 3 and Mariner 4 were identical spacecraft designed to carry out the first flybys of Mars. Mariner 3 was launched on November 5, 1964, but the shroud encasing the spacecraft atop its rocket failed to open properly, dooming the mission. 3 weeks later, on November 28, 1964, Mariner 4 was launched successfully on a 7.5-month voyage to the Red Planet. Mariner 4 flew past Mars on July 14, 1965, providing the first close-up photographs of another planet. The pictures, gradually played back to Earth from a small tape recorder on the probe, showed impact craters. It provided radically more accurate data about the planet. A surface atmospheric pressure of about 1% of Earth's and daytime temperatures of 100 °C were estimated. No magnetic field or Martian radiation belts were detected. The new data meant redesigns for then-planned Martian landers, and showed life would have a more difficult time surviving there than previously anticipated. NASA continued the Mariner program with another pair of Mars flyby probes, Mariner 6 and 7. They were sent at the next launch window, and reached the planet in 1969. During the following launch window, the Mariner program again suffered the loss of one of a pair of probes. Mariner 9 successfully entered orbit about Mars, the first spacecraft ever to do so, after the launch time failure of its sister ship, Mariner 8. When Mariner 9 reached Mars in 1971, it and 2 Soviet orbiters found that a planet-wide dust storm was in progress. The mission controllers used the time spent waiting for the storm to clear to have the probe rendezvous with, and photograph, Phobos. When the storm cleared sufficiently for Mars' surface to be photographed by Mariner 9, the pictures returned represented a substantial advance over previous missions. These pictures were the first to offer more detailed evidence that liquid water might at one time have flowed on the planetary surface. They also finally discern the true nature of many Martian albedo features. For example, Nix Olympica was one of only a few features that could be seen during the planetary dust storm, revealing it to be the highest mountain on any planet in the entire solar system, and leading to its reclassification as Olympus Mons. Viking program. The Viking program launched Viking 1 and 2 spacecraft to Mars in 1975. The program consisted of 2 orbiters and 2 landers. These were the first 2 spacecraft to successfully land and operate on Mars. The primary scientific objectives of the lander mission were to search for biosignatures and observe meteorologic, seismic and magnetic properties of Mars. The results of the biological experiments on board the Viking landers remain inconclusive, with a reanalysis of the Viking data published in 2012 suggesting signs of microbial life on Mars. The Viking orbiters revealed that large floods of water carved deep valleys, eroded grooves into bedrock, and traveled thousands of kilometers. Areas of branched streams, in the southern hemisphere, suggest that rain once fell. Mars Pathfinder. Mars Pathfinder was a U.S. spacecraft that landed a base station with a roving probe on Mars on July 4, 1997. It consisted of a lander and a small 10.6 kilograms wheeled robotic rover named Sojourner, which was the first rover to operate on the surface of Mars. In addition to scientific objectives, the Mars Pathfinder mission was also a proof of concept for various technologies, such as an airbag landing system and automated obstacle avoidance, both later exploited by the Mars Exploration Rovers. Mars Global Surveyor. After the 1992 failure of NASA's Mars Observer Orbiter, NASA retooled and launched Mars Global Surveyor. This mission was the first successful United States mission, and the first fully successful mission overall, to the Red Planet in 2 decades when it launched November 7, 1996, and entered orbit on September 12, 1997. After a year and a half trimming its orbit from a looping ellipse to a circular track around the planet, the spacecraft began its primary mapping mission in March 1999. It observed the planet from a low altitude, nearly polar orbit over the course of 1 complete Martian year, the equivalent of nearly 2 Earth years. Mars Global Surveyor completed its primary mission on January 31, 2001, and completed several extended mission phases. The mission studied the entire Martian surface, atmosphere, and interior, and returned more data about the Red Planet than all previous Mars missions combined. The data has been archived and remains available publicly. Among key scientific findings, Global Surveyor took pictures of gullies and debris flow features that suggest there may be current sources of liquid water, similar to an aquifer, at or near the surface of the planet. Similar channels on Earth are formed by flowing water, but on Mars the temperature is normally too cold and the atmosphere too thin to sustain liquid water. Nevertheless, many scientists hypothesize that liquid groundwater can sometimes surface on Mars, erode gullies and channels, and pool at the bottom before freezing and evaporating. Magnetometer readings showed that the planet's magnetic field is not globally generated in the planet's core, but is localized in particular areas of the crust. New temperature data and close-up images of the Martian moon Phobos showed that its surface is composed of powdery material at least 1 meter thick, caused by millions of years of meteoroid impacts. Data from the spacecraft's laser altimeter gave scientists their first 3D views of Mars' North Polar ice cap. On November 5, 2006, MGS lost contact with Earth. NASA ended efforts to restore communication on January 28, 2007. Mars Odyssey and Mars Express. In 2001, NASA's Mars Odyssey orbiter arrived at Mars. Its mission is to use spectrometers and images to hunt for evidence of past or present water and volcanic activity on Mars. In 2002, it was announced that the probe's gamma-ray spectrometer and neutron spectrometer had detected large amounts of hydrogen, indicating that there are vast deposits of water ice in the upper 3 meters of Mars soil within 60° latitude of the South Pole. On June 2, 2003, the European Space Agency's Mars Express set off from Baikonur Cosmodrome to Mars. The Mars Express craft consists of the Mars Express orbiter and the lander Beagle 2. Although the landing probe was not designed to move, it carried a digging device and the smallest mass spectrometer created to date, as well as a range of other devices, on a robotic arm in order to accurately analyze soil beneath the dusty surface. The orbiter entered Mars orbit on December 25, 2003, and Beagle 2 entered Mars atmosphere the same day. However, attempts to contact the lander failed. Communications attempts continued throughout January, but Beagle 2 was declared lost in mid-February, and a joint inquiry was launched by the UK and ESA. The Mars Express orbiter confirmed the presence of water ice and carbon dioxide ice at the planet's south pole, while NASA had previously confirmed their presence at the north pole of Mars. MEL and Phoenix. NASA's Mars Exploration Rover mission is an ongoing robotic space mission involving two rovers, Spirit and Opportunity, exploring the planet Mars. It began in 2003 with the sending of the two rovers MERA Spirit and MERB Opportunity to explore the Martian surface and geology. The mission's scientific objective was to search for and characterize a wide range of rocks and soils that hold clues to past water activity on Mars. The mission is part of NASA's Mars Exploration Program, which includes 3 previous successful landers, the 2 Viking program landers in 1976 and Mars Pathfinder probe in 1997, Mars Reconnaissance Orbiter. Mars Reconnaissance Orbiter is a multi-purpose spacecraft designed to conduct reconnaissance and exploration of Mars from orbit. The $720 million USD spacecraft was built by Lockheed Martin under the supervision of the Jet Propulsion Laboratory, launched August 12, 2005, and attained Martian orbit on March 10, 2006. The MRO contains a host of scientific instruments such as the HiRISE camera, CTX camera, CRISM, and SHARAD. The HiRISE camera is used to analyze Martian landforms, whereas CRISM and SHARAD can detect water, ice, and minerals on and below the surface. Additionally, MRO is paving the way for upcoming generations of spacecraft through daily monitoring of Martian weather and surface conditions, searching for future landing sites, and testing a new telecommunications system that enable it to send and receive information at an unprecedented bit rate, compared to previous Mars spacecraft. Data transfer to and from the spacecraft occurs faster than all previous interplanetary missions combined and allows it to serve as an important relay satellite for other missions. Rosetta and Dawn swingbys. The ESA Rosetta space probe mission to the comet 67P Churyumov-Gerasimenko flew within 250 km of Mars on February 25, 2007 in a gravitational slingshot designed to slow and redirect the spacecraft. The NASA Dawn spacecraft also used the gravity of Mars to change direction and velocity, and did a little science in conjunction with the many probes already there. Dawn passed the Red Planet in February 2009. Phobos Grunt. In November 8, 2011, Russia's Roscosmos launched an ambitious mission called Phobos Grunt. It was a lander aimed to retrieve a sample back to Earth from Mars moon Phobos, and place the Chinese Yingguo-1 probe in Mars orbit. The Phobos Grunt mission suffered a complete control and communications failure shortly after launch and was left stranded in low Earth orbit, later falling back to Earth. The Yingguo-1 satellite and Phobos Grunt underwent destructive re-entry on January 15, 2012, finally disintegrating over the Pacific Ocean. Curiosity rover. The NASA Mars Science Laboratory mission with its rover named Curiosity, was launched on November 26, 2011. The rover carries instruments designed to look for past or present conditions relevant to the past or present habitability of Mars. The Curiosity rover landed on Mars and Aeolis Palus in Gale crater, between Peace Vallis and Aeolis Mons, on August 6, 2012 at 5:14 and 39 seconds UTC. The coordinates of the landing site are, MAVEN. NASA's MAVEN is an orbiter mission to study the atmosphere of Mars. It will also serve as a communications relay satellite for robotic landers and rovers on the surface Mars. MAVEN was launched November 18, 2013 and reached Mars on September 22, 2014. Mars Orbiter Mission. The Mars Orbiter Mission, also called Mangalyaan, was launched on November 5, 2013 by the Indian Space Research Organisation. It was successfully inserted into Martian orbit on September 24, 2014. The mission is a technology demonstrator, and as secondary objective, it will also study the Martian atmosphere. This is India's first mission to Mars, and with it, ISRO became the fourth space agency to successfully reach Mars after the Soviet Union, NASA and ESA. It also made India the first country to reach Mars orbit on its first attempt. Future missions. In August 2012, NASA selected InSight, a $425 million lander mission for 2016, with a drill and seismometer to determine the interior structure of Mars. As part of the ExoMars program, ESA and the Russian Federal Space Agency plan to send the Trace Gas Orbiter and the Schiaparelli lander to Mars in 2016, and the ExoMars rover in 2018 to search for past or present microscopic life on Mars. The Finnish-Russian METNET concept would, if implemented in 2015, use multiple small meteorological stations on Mars to establish a widespread observation network to investigate the planet's atmospheric structure, physics and meteorology. The METNET precursor or demonstrator was considered for a piggyback launch on Phobos Grunt, and on the planned 2016 and 2018 ExoMars landers. The Mars Grunt is a Russian mission concept to bring a sample of Martian soil to Earth. The ISRO plans to send a follow-up mission to its Mars Orbiter mission in the 2017 to 2020 timeframe. A ESA-NASA team produced a 3-launch architecture concept for a Mars sample return, which uses a rover to cache small samples, a Mars ascent stage to send it into orbit, and an orbiter to rendezvous with it above Mars and take it to Earth. Solar electric propulsion could allow a 1-launch sample return instead of 3. The Mars Scout program's SEIM would involve a probe grazing the upper atmosphere of Mars to scoop up dust and air for Earth return. The Mars 2020 rover mission by NASA would be launched in 2020, and it would be based on the Mars Science Laboratory design. The scientific payload will be focused on astrobiology. The United Arab Emirates announced that the first mission of his space agency will be to send an unmanned mission to Mars by 2021. Other future mission concepts include new polar probes, Martian aircraft and a network of small meteorological stations. Long-term areas of study may include Martian lava tubes, resource utilization, and electronic charge carriers in rocks. Micromissions are another possibility, such as piggybacking a small spacecraft on an Ariane 5 rocket and using a lunar gravity assist to get to Mars. Past missions. Starting in 1960, the Soviets launched a series of probes to Mars. The first successful flyby of Mars was on July 14, 15, 1965, by NASA's Mariner 4. On November 14, 1971, Mariner 9 became the first space probe to orbit another planet when it entered into orbit around Mars. The amount of data returned by probes increased dramatically as technology improved. The first to contact the surface were 2 Soviet probes, Mars 2 lander on November 27 and Mars 3 lander on December 2, 1971. Mars 2 failed during descent and Mars 3 about 20 seconds after landing. Mars 6 failed during descent but did return some corrupted atmospheric data in 1974. The 1975 NASA launches of the Viking program consisted of 2 orbiters, each with a lander that successfully touched down in 1976. Viking 1 remained operational for 6 years, Viking 2 for 3. The Viking landers relayed the first color panoramas of Mars and the Viking orbiters mapped the surface so well that the images remain in use. The Soviet probes Phobos 1 and 2 were sent to Mars in 1988 to study Mars and its 2 moons, with a focus on Phobos. Phobos 1 lost contact on the way to Mars. Phobos 2, while successfully photographing Mars and Phobos, failed before it was set to release 2 landers to the surface of Phobos. Roughly 2/3 of all spacecraft destined for Mars have failed without completing their missions, and it has a reputation as difficult space exploration target. Missions that ended prematurely after Phobos 1 and 2 include Mars Observer, Mars 96, Mars Climate Orbiter, Mars Polar Lander with Deep Space 2, Nozomi, Beagle 2, and Phobos Grunt with Yingguo 1. Following the 1993 failure of the Mars Observer Orbiter, the NASA Mars Global Surveyor achieved Mars orbit in 1997. This mission was a complete success, having finished its primary mapping mission in early 2001. Contact was lost with the probe in November 2006 during its 3rd extended program, spending exactly 10 operational years in space. The NASA Mars Pathfinder, carrying a robotic exploration vehicle Sojourner, landed in the Ares Vallis on Mars in the summer of 1997, returning many images. Phoenix landed on the North Polar region of Mars on May 25, 2008. Its robotic arm dug into the Martian soil and the presence of water ice was confirmed on June 20, 2008. The mission concluded on November 10, 2008 after contact was lost. In 2008, the price of transporting material from the surface of Earth to the surface of Mars was approximately $309,000 per kilogram. Rosetta came within 250 km of Mars during its 2007 flyby. Dawn flew by Mars in February 2009 for a gravity assist on its way to investigate Vesta and Ceres. Manned mission proposals. Many people have long advocated a manned mission to Mars as the next logical step for a manned space program after lunar exploration. Aside from the prestige such a mission would bring, advocates argue that humans would easily be able to outperform robotic explorers, justifying the expense. Aerospace engineer Bob Zubrin is one of the proponents of such missions. Some critics contend unmanned robots can perform better than humans at a fraction of the expense. If life exists on Mars, a manned mission could contaminate it by introducing earthly microbes, so robotic exploration would be preferable. A list of hypothetical or proposed manned Mars missions is located at Manned Mission to Mars. See also, colonization of Mars. ESA. The ESA has plans to land humans on Mars between 2030 and 2035. This will be preceded by successively larger probes, starting with the launch of the ExoMars probe and a planned joint NASA-ESA Mars sample return mission. NASA, manned exploration by the United States was identified as a long-term goal in the Vision for Space Exploration announced in 2004 by then U.S. President George W. Bush. The planned Orion spacecraft would be used to send a human expedition to Earth's moon by 2020 as a stepping stone to a Mars expedition. On September 28, 2007, NASA Administrator Michael D. Griffin stated that NASA aims to put a person on Mars by 2037. Zubrin, Mars Direct, a low-cost human mission proposed by Robert Zubrin, founder of the Mars Society, would use heavy-lift Saturn V-class rockets, such as the Ares V, to skip orbital construction, LEO rendezvous, and lunar fuel depots. A modified proposal, called Mars to Stay, involves not returning the first immigrant explorers immediately, if ever. Probing difficulties. The challenge, complexity and length of Mars missions make it likely that failures can occur. The high failure rate of missions launched from Earth attempting to explore Mars was informally called the Mars Curse, or Martian Curse. The phrase galactic gull, or Great Galactic Gull, referring to a fictitious space monster that subsists on a diet of Mars probes, was coined in 1997 by Time magazine journalist Donald Neff, and is sometimes facetiously used to explain the recurring difficulties. 2 Soviet probes were sent to Mars in 1988 as part of the Phobos program. Phobos 1 operated normally until an expected communications session on September 2, 1988 failed to occur. The problem was traced to a software error, which deactivated attitude thrusters causing the spacecraft's solar arrays to no longer point at the Sun, depleting Phobos 1 batteries. Phobos 2 operated normally throughout its cruise and Mars orbital insertion phases on January 29, 1989, gathering data on the Sun, interplanetary medium, Mars, and Phobos. Shortly before the final phase of the mission, during which the spacecraft was to approach within 50 m of Phobos' surface and release 2 landers, one a mobile hopper, the other a stationary platform, contact with Phobos 2 was lost. The mission ended when the spacecraft signal failed to be successfully reacquired on March 27, 1989. The cause of the failure was determined to be a malfunction of the onboard computer. Just a few years later in 1992 Mars Observer, launched by NASA, failed as it approached Mars. Mars 96, an orbiter launched on November 16, 1996 by Russia failed, when the planned second burn of the Block D2 fourth stage did not occur. Following the success of Global Surveyor and Pathfinder, Another spate of failures occurred in 1998 and 1999, with the Japanese Nozomi orbiter and NASA's Mars Climate Orbiter, Mars Polar Lander, and Deep Space 2 penetrators all suffering various fatal errors. Mars Climate Orbiter was noted for mixing up U.S. customary units with metric units, causing the orbiter to burn up while entering Mars' atmosphere. Timeline of Mars exploration, source, totals, timeline, future missions, understudy, undeveloped concepts, Mars 4 nanometers and Mars 5 nanometers are Euro projects intended by the Soviet Union for heavy Marsikhod and Mars sample return missions by launching on N-1 rocket that has never flown successfully. Voyager a Euro USA, 1970s a Euro 2 orbiters and 2 landers, launched by a single Saturn V rocket. Mars Aerostat a Euro-Russian-French balloon mission, originally planned for the 1992 launch window, postponed to 1994 and then to 1996 before being cancelled. Mars Environmental Survey a Euro set of 16 landers planned for 1999 a Euro 2009, Mars 98 a Euro-Russian mission including an orbiter, lander, and rover, planned for 1998 launch opportunity, Mars Surveyor 2001 lander a Euro October 2001 a Euro Mars lander, Beagle 3 a Euro 2009 British lander mission meant to search for life, past or present. Netlander 2007 or 2009 a Euro Mars Netlanders, Mars Telecommunications Orbiter a Euro September 2009 a Euro Mars Orbiter for Telecommunications, Mars Astrobiology Explorer Cache a Euro 2018 rover, Kitty Hawk a Euro Mars Airplane Micromission, proposed for December 17, 2003, the centennial of the Wright brothers' first flight. Its funding was eventually given to the 2003 Mars Network project. Tumbleweed rover. See also. References. Further reading, Mars a Euro a Warmer, Wetter Planet by Jeffrey S. Cargill, The Compact NASA Atlas of the Solar System by Ronald Greeley and Raymond Batson, Mars. The NASA Mission Report/edited by Robert Godwin ISBN 1-896522-62-9, external links, Mars program by the American JPL, Mars Rovers Newsroom, Next on Mars, an extensive overview of NASA's Mars exploration plans, Catalogue of Soviet Mars images collection of Russian Mars probes images. NASA History Series publications, Simplified Study of Orbits to Land on Mars and Return to Earth, NASA Program and Missions, Mapping Mars, Now and in History, Mars Exploration Art, Mars by Rosetta.